Henderson, you okay? All right, guys. Last one as a group, and then we'll call it a day, and you guys will do the group work, and then we'll go from there. From the 2003 exam, the AB subscore was 2.68, so this was kind of tough. Let's see what made this one tough. Let f be a function defined on the closed interval, negative 3 to 4, where f of 0 equals 3. The graph of f prime, so this time I have f prime. The derivative of f consists of one line segment and a semicircle shown above. On what intervals, if any, is f increasing? Justify your answer. Oh, that's it. There you go. That's perfect. So f, and I'm using the stem, f is increasing on the interval, parenthesis, negative 3 all the way to what? Negative 2. And you can actually use brackets if you want, but that's fine right there. Since f prime is on this specific interval. You can probably get away with saying, with just stopping there since f prime is positive, but I would put that one little sentence there. Are we still okay? Okay. Letter B. Find the x-coordinate of each point of inflection on the graph of f on the open interval negative 3 to 4. Justify your answer. So, where f prime has a max or min, yes, you can say that. I like that answer as the second best answer. The best answer is, in my opinion, is what? Where f prime changes from decrease to increase or vice versa. So I have a point, f has a point of inflection where and where? No, not negative 2.
Oh, 0.
0 and 2. So there it is. So make sure to write f. F has points of inflection at x equals, I'm going to put I read a graph left to right, so put the negative 2 first. Oh, yes. At 0, and what? And 2. At 0 and x equals 2. Since f prime is changing from, which one does it change from first? Decreasing to increasing, and vice versa. And vice versa at those specific x values. This is not an interval. These are x values. This is a moment.
So, in the case that it had extremes, right? It had maximums, but it didn't change. That would be a further.
You can't have max and mims if you don't go from increasing to decreasing or vice versa. But remember what's happening. F prime is going. You can. What Houston said is perfectly fine. So you could have said, let me write the alternate. F has points of inflection at x equals 0 and x equals 2, since f prime has extrema at those x values. Extrema is Latin for extreme values. Extreme means max min. You can say what's in blue. Does that make sense, guys? Okay. All right. Letter C. So far, none of this looks crazy. Find an equation of the line tangent to the graph of f at the point 0, 3. What do I need for a tangent line? Point of slope. Do they give me a point?
Yes.
Can I get a slope?
Yes.
Yes. This graph here is f prime. So let me write my point here. My point is 0, 3, and I need f prime of 0. So I go to my graph. What is my f prime of 0, Ms. Cruz? Negative 2. There it is, guys. I'm done. Y minus 3 equals negative 2. X minus 0. Is that all they wanted? Done. You can leave it alone.
F prime of 0, not f prime of 3.
F prime, that's the x value. That's my point. So f prime is 0. I think that's it. They don't want me to do anything with it, right? What's up, Vic? What's up, Johnson? Sorry. Because you're right next to Vic. Yes. You could also write it like this. Both are accepted. How do we feel? Okay. Last, find f of negative 3 and f of 4. Show the work that leads to your answer. I love this. Guys, this is like saying what's my position at -3? What's my position at 4? So f of -3 equals, do they give me an initial position? Yes, they do. This one, f of 0 plus integral from 0 to -3 of f prime of x. This is just like saying find my position at time equals -3. I know there's no such thing as time. So my initial position given plus how much it has moved.
And how do you know it's the initial?
Well, this is the only one that they gave me right here. See, at the point 0.03. I think it's also embedded in the problem right there. F of 0 equals 3. Yes, Sanderson.
How do we know to add f of 0?
Oh, because that's my initial. Like, where does f of 0 start? At 3, the y value 3. And then you got to add or subtract how much it has moved. You know what I mean? All right, guys. Now it's just geometry. So I'm going to write 3 plus, I'm going to put bracket, it's from 0 to -3. So here it is. From 0 to -3. So this looks like a triangle to me. 2 times 2 divided by 2. So that looks like 2.
And then like from 0 to -2 would be negative, right? And then
It would, but because my limits are backwards,
It'd be positive.
mhm. And then this part right here,
Would be negative.
let's see, yep, 1 times 1, so that's a half. So minus a half. Yes.
would we be able to just like,
Leave it like that? Yes.
well, no, I was gonna say do it regularly, like make the 0 to -2 negative, and then
Yes. Like put the -3 in the bottom and the 0 on the top. But then you have to, instead of a plus, you gotta have to make it a, yes. 3 plus, is that 3/2?
Oh,
This is perfectly fine. Oh, tell me, what happened?
Sorry for my hair.
Oh, okay. Sorry, miss. You're good. You're good. 9 over. Oh, no. Leave it. I was gonna multiply it by 3 for some reason. Times 2. Yeah, 6 over 2, 6, 79. 9 over 2. That's my final answer. Now I need f of 4. I'm doing the same thing, guys. I'm not doing anything. F of 0 plus integral from 0 to of f prime. So 3 plus bracket. Let's see what it is from 0 to 4. Is this helping, by the way?
Yes.
Okay, geometry. So here it is, guys.
so 1/2 base times. No.
It would be pi squared over 2.
So what's my radius here? What's my radius here, Bernal Sierra? Yeah, good job. 2, miss. How'd you figure out that it was 2? Okay, good job. Yeah,
So let's
you got it. So 2 pi, but it's below the x-axis. Oh, well, first, okay, hold on. Be careful. That's not the area that I want. This is the area that I want. Do you guys see that?
I see it, but I
Wait,
don't
okay,
find
so
the
can we,
square.
can we make a square and then
Yeah, the rectangle. Right? Yep. So 2 times 4, what's that? 8. And I'm going to subtract 2 pi. Now, because it's all below the x-axis,
Negative.
put a negative. So I'm going to write, I guess I'll put a minus here like that. And what was it? 8 minus 2 pi? So 3 minus 8, what's that? -5? So 2 pi.
Automatically know you need to have like what kind of triangle.
Oh, because you want the bounded area between the x-axis and the curve. And that's what's bounded between the x-axis and the curve.
So whatever is closest to the x-axis.
Yeah.
you try to find.
hmm The bounded area. You know what I mean? Because the bounded area is telling us how much I moved. All right, let's look at the rubric for the 2003 guys, and then. Oh, I didn't finish it.
oh, there's 2 more.
No, those others are in group. 2003. Let's look at that real quick. By the way, I haven't looked at these rubrics yet. I know it's hot, guys. All right, here it is. Look how they wrote it. They wrote it exactly how we wrote it, but they put brackets. That's fine. We got the 2 points. F prime changes from decreasing to increasing at x equals 0, and from increasing to decreasing at x equals 2. I love it. 2 points. Negative 2x plus 3, they wrote it like this in mx plus b form, Zamora Johnson, but ours is just as fine. And, yep. Oh, did we get? Oh, yeah, we got 9 over 2 and negative 8 plus 2 pi. Oh, no, wait. Negative 5 plus 2 pi. Yep, there it is. We got them all, guys. What do you
think? Why do you think people scored so low on this?
I think they messed up with letter D. I think on letter D, like they didn't. Well, letter D was worth the majority of them. Letter D was worth 4 points. So I think people didn't get the area of that. Like they didn't find it correctly. Area of a rectangle minus area of a semicircle. All right, guys, that's it. This is our last. Let's take care of these two as a group and then upload it to Canvas. If we can get it all done today, maybe tomorrow we can go over review questions. But if not, no big deal. Yeah, let me know where we have issues.